Welcome back. This is the last video in the stoichiometry series, and today's topic is going to deal with percent yield. So the first thing we need to do is to understand what percent yield. It says it's the ratio between the mass acquired from a reaction and the expected amount. Mass acquired from the reaction is what you can actually put on a balance and measure after you've done the experiment, and the expected amount is what you got when you did the stoichiometric conversions that we've done in the previous videos. Our formula looks like this. Percent yield is equal to the actual yield divided by the theoretical yield times 100. The actual yield is the one that we measured. We found out how much we actually got when we did the experiment. And the theoretical yield is what we did to find it when we did the stoichiometric conversions. So those are the calculations. Another way you could then say this would be to say that the percent yield equals the measured amount, the amount you put on the balance, divided by the calculated amount, times 100. A recipe says that it will make 12 cookies. However, after you make them, you only have 10 cookies. We want to know then what our percent yield will be from this recipe. Again, we have our actual divided by theoretical. Our example problem says that we expect to make 12 cookies. That then is our theoretical yield. It is what we assume we will get when we do this. Then it says after you make them, like saying after you've done the experiment, you only have 10 cookies. Because you have 10 cookies, that becomes our actual yield. So 10 divided by 12 times 100 is equal to 83.3%. That means that we didn't get a perfect experiment. If we were perfect, we would have gotten 12 cookies, which would have been our expected. That would have been 100% yield. Instead, we got less than that. We got 83.3%, which isn't bad, but it's not perfect. Keep in mind that perfection is something that rarely happens in science. Now let's look at a chemical example. In a lab, aspirin, C9H8O4, was synthesized from combining salicylic acid and ethanoic anhydride. The student expected to get 45 grams of aspirin, however, only 38.2 grams were recovered. What is the percent yield? Here's our equation. Now we need to figure out which things go in which places. All right, so we write our equation here, and now we need to figure out what goes on top, what goes on bottom. It says the student expected to get 45 grams of aspirin. This is what was expected, not what was actually gotten. Hence, that would be our theoretical yield, which goes on bottom. Next, it says only 38.2 grams were recovered. That means that's what we got when we did the experiment, which means that becomes our actual yield. Now it's simple math. 38.2 divided by 45.0 times 100 gives us a percent yield of 84.9%. Now that you know how to get a percent yield, we should also know what it indicates, what it tells us, and why we want to know that. So if we want to know why we should find a percent yield, it has a lot to do with economy. When a process is done, they want to look at how efficient was it? How much did I get out? Is this a process that's good? Can I make money off of this? Is basically what a lot of the percent yield is used for. Industries often use this to figure out a cost-benefit analysis. Basically, the idea is they're trying to make as much as they can while wasting as little as they can. So in this time, if we were an aspirin producer, looking at our last problem, we'd want to know what percent can we get out? Is it cost efficient to do it? Is there a way that we could maybe make it more efficient, make our procedure produce more and waste less? In an ideal world, you would get 100%, meaning that everything gets used up and converted into product. In real life, in real science, that pretty much never happens. Generally speaking, you're going to find a percent yield that is less than 100%. Not all of it will react. What we would then want to look at is sources of error. Now I want to take a moment and pause and look at what scientific error is and what it means. One of the things you could keep in mind is that errors don't necessarily mean you have done something wrong. Do not say things like, I miscalculated. If you miscalculated, fix that. What this is talking about is things that could be introduced into either procedure or materials that cause our values to be something other than what we expected. When we're talking about scientific error, we're talking about the difference between what we got and what was true, what should have been. There are lots of things that can cause error. For example, if the equipment you're using were somehow faulty, perhaps it always measured slightly off, or that it was inconsistent, that can introduce error. Other things that can happen would be a fluctuation in the environment, such as if it is more humid in the air today, it might affect how much could react, or if there was still moisture in your product, in your precipitate. Other things that can happen would be a certain procedure. Perhaps there's something that you did that caused it to react differently or to react with another substance, something that could be introduced to the experiment. There's also a certain matter of human error. For example, let's say that if you were measuring in the graduated cylinder, if you didn't squat down and get your eye level with the meniscus, you might not have a perfect measurement of how much was in there. All those things can introduce error into your measurement and cause you to be less than 100%. And those would be things that you would account for when you do a lab write-up. So what happened if you had less than 100%? There are several things that could have happened. If the reaction was not complete, meaning some of the reactants didn't use up, we might not get all of the product we had expected. If we have side reactions that happen, if we may have things converted into unintended substances. And as some of you have noticed when you've done certain labs, it's hard sometimes to get all of your product into the thing that you're weighing. If you have some that's still left in the beaker or in a graduated cylinder, or if some were scraped onto filter paper, all those things could make it to where you didn't get all of your product into the final container. This happens in industry as well. When they're making commercial products, there are times where a certain amount of the product is left in containers that made them, and that accounts for some of the loss. Now, occasionally, you'll find that you get a yield that's greater than 100%. That means something definitely has gone haywire. We may have gotten something where we have impurities in our products. It is also possible that maybe not all the water was evaporated off, or if we have other reactions that produce other products, other precipitates, we may have created things we didn't intend. So if you get something greater than 100%, know that something has gone wrong. There is some source of error. Again, it may not be that you did something wrong, but that there is something that happened that introduced error into your experiment. So in today's lesson, we have figured out what percent yield, how to calculate it, and what it means. Thanks for joining us today. This was the last one in the Stoichiometry series, so if you need to review any of the previous ones, feel free to click on the links, and thanks for watching.